We're going to start topic 6 today in Advanced Algebra 1, and we're going to start looking at exponents and the properties of exponents. And in particular today we're going to look at products. Okay, remember that a product is an answer to a multiplication problem, so we're going to have some multiplication involved. We have 3 different rules that are associated with multiplying or products when it comes to exponents. And the first basic rule is that when we are multiplying terms that have the same base, okay, when we deal with exponents, in this case the base is b and the exponent is the power or the value, the exponent, the power that the base is raised to. So for example, if I had 2 raised to the third power, the base is 2 and the exponent is 3. And what that means is, that means the base gets taken times itself 3 times, or the exponent numbered times. So 2 times 2 times 2, that would equal 8. So when I refer to the base is the term that is being raised to the exponent. Okay, and I will refer to this as the exponent or the power. Well, when we are multiplying terms together that have the same base, both of these have base b, then we have a rule for that, and that rule is to keep the base, so the base remains b, and we add the powers together. So we would add n plus m. It's a little bit blurry, I'm not sure if you can see that or not, but this is b to the n power, this is b to the m power. So when I multiply those together, I just add their exponents together. To give you an example of that, if you look down here at example 1, you have 7 raised to the third power times 7 raised to the fifth power. Because the base is the same, we can apply this first rule, and so the base will stay the same, and I will just add the exponents together. So 3 plus 5 is 8. That would be 7 to the 8th. And you don't need to multiply that out, you can just leave your answer in terms of an exponent. Okay, here's another example where we have the base in each expression is the same, all base 9, so I apply my rule for multiplication. The base stays the same. Notice I'm not multiplying the bases together, but the base remains the same, and we add the exponents together. Okay, this is 2 plus 8 is 10. Don't forget there's an exponent here. You don't see the 1, but this is 9 to the first power, so we'd have to take 1 plus 8 plus 2. I'll write that out. 1 plus 8 plus 2, and that would equal 9 to the 11th power. And again, I'm not going to multiply this out. That'd be a really, really big number. We're going to leave our answer in terms of an exponent. Okay, example 3, I've got the same base. This is a base of -5. This is to the first power. This is a base of -5 to the 7th power. So I leave the base the same, and I'm going to leave it in parentheses. 1 plus 7. Okay, we always add our exponents together when we're multiplying. So the base stays the same, and it's raised to the 8th power. We can do the same thing when our base is a variable. X to the 4th power times x to the 3rd power. The base would stay the same, and we'd add the exponents. Okay, example 5. The base stays the same, and I add the exponents. Again, this is just x, so you know that that's x to the 1st power. So 2 plus 6 plus 1 would be x to the 9th. Okay, that's our first basic rule for multiplying terms that contain the same base. We leave the base the same and we add their exponents. Now the second rule is called a power of a power. So you might see a base raised to an exponent and then it's raised to another power or another exponent. In this situation, the base stays the same and we multiply the exponents together. We get n times m. So if you look at the second set of problems down here, it says simplify the expression. This is a base 2 raised to the 5th power, and all that's raised to the 3rd power. So we have a power that's raised to another power. The base stays the same, so we leave it at 2, and this time we multiply. We're going to take 5 times 3. So that's going to be 2 to the 15th power. 5 times 3 is 15. And again, don't multiply that out, just leave your answer with an exponent. Okay, next example, I've got -6 raised to the 2nd power, and I'm raising all that to the 5th. So I leave it as -6. The base doesn't change, but it's a power raised to another power, so we multiply. 2 times 5 is 10. Okay, x to the second raised to the fourth. The base stays the same, and I multiply my powers. 2 times 4 is 8. Okay, here I'm multiplying my powers. I get n to the 18th. Okay, this you have a sum inside, but it's raised to a power. All of this is raised to the 5th power, and then it's raised to the 4th power. So the only thing we can do is we can apply our rule for these exponents. So we're going to leave m plus 1 in parentheses. 5 times 4 is 20. That's that sum to the 20th power. Can't do anything else with that. And here we have a difference inside the parentheses. This difference, y minus 2, is a difference because it's subtraction. It's all raised to the 6th power, and then that's going to be raised to the 2nd power. So we have to leave the y minus 2 in parentheses, and we apply our rules. We get to the 12th power. I can't do anything more with that. I'm just going to leave my answer that way. Okay, and then the last rule up here is called the power of a product. And remember, a product is multiplication. So you might have in parentheses a product of two things, b times c, and you want to raise all that to the power of n. Well, we break this product up, and we take b and we raise it to the n, and we take c and we raise it to the n. Both of those factors, okay, when I multiply two numbers together, they're both called factors. Both of those factors get raised to that exponent. So down at the bottom of this, you've got some examples that show a power of a product. Okay, notice we have a product inside parentheses. There's multiplication. So I'm going to take each one of those factors, 24, and I'm going to raise it to the 8th power, times, take 13, and raise it to the 8th power. And I'm going to leave my answer like that because these are very, very large numbers. So I'm just going to leave my answer like that. Okay, here I've got a product of three things. I'm taking 9 times x times y, and I want to raise it all to the 2nd power. So I've got to break this into its factors. I take 9 and I raise it to the 2nd power. Okay, I take x to the first, this is x to the first, and I'm going to raise it to the 2nd power, times. And I'm going to take y, this is y to the first, and I want to raise it to the 2nd power. So it's kind of like distributing that power outside parentheses to everything inside the parentheses. This one we are going to simplify. 24 to the 8th power, 13 to the 8th power, those are huge, huge numbers. But 9 to the 2nd power, we know that one. We can do that one without a calculator. 9 to the 2nd power, 9 squared is 81. Here I apply my rule. Same rule I encountered up here. This is a power raised to another power, so there's where I multiply. And same thing here, I'm going to multiply those exponents. And my final answer is 81 x squared y squared. Okay, on 14, this is a product inside here. Negative 4 gets raised to the 2nd power, sorry, that's a 2, times z to the first gets raised to the 2nd power. When I take a negative 4 and I square it, negative 4 times negative 4, that's a positive 16. And then here I'm going to apply my rules. Power raised to a power, I multiply. So that's going to become z squared. Okay, we would actually call this negative 4 is like a coefficient. We take the coefficient to the power, we take z to the power. Okay, a little different here on example 15. You notice that the negative here was inside the parentheses. So when I squared the 4, I squared the negative with it. This is different where the negative is outside the parentheses. So that negative, that's like a negative 1 times 4z to the 2nd power. Okay, I'm going to evaluate exponents first. If I think of PEMDAS, exponents come first, so 4 squared times z to the first. I'm going to square it. So I'm going to take negative 1 times 4 squared is 16. Okay, apply my rule for exponents and I get z squared. I put all that together, negative 1 times 16, that's going to be a negative 16 z squared. Notice the difference over here that we ended up with a positive term as an answer. That's because the negative was inside the parentheses and was squared. Over here the negative is outside of the parentheses, therefore it doesn't get squared. That's why it's a negative for your final answer. Okay, here we're going to take 9 and raise it to the 4th power. We got m to the 3rd, we want to raise it to the 4th power. And we've got n to the 1st, and we want to raise it to the 4th power. Okay, 9 to the 4th, 9 times 9 is 81, times another 9 is 729, times another 9. It'll be pretty large. I'm just going to leave that as 9 to the 4th. If I had a calculator, we could do that. Here I'm going to apply my rules for exponents. So that's going to be m to the 12th, and this would be n to the 4th. Okay, here you got only the 2x cubed is squared. So we're going to apply that. Say that's 2 squared times x to the 3rd squared times, now we have this x to the 4th. Okay, 2 squared is 4. X to the 3rd squared, we apply our rule for power raised to a power, so that's going to become x to the 6th. Okay, times, this is x to the 4th. Now we're not done because we can go back. Here's a rule. Same base, right? What was the rule at the very beginning? When the base is the same and we're multiplying, we're going to add our exponents. That's going to become x to the 10th, 4x to the 10th. So you're going to start encountering problems where you have multiple rules to use in the same problem. Okay, let's do the last couple here. Okay, this is a negative 10. Notice the negative is inside the parentheses, so I get negative 10 squared times x to the 6th squared times x to the 3rd. I'm only applying this squared to what's inside parentheses there. Negative 10 squared, that's a positive 100. This would be times x power raised to a power. We multiply exponents times x to the 3rd. Here's a product. I'm multiplying these two. The base is the same, so the base stays the same, and I add exponents. Okay, my final answer would be 100x to the 15th. Okay, and then the last example here, I'm going to distribute that power and say that's 3 to the 3rd times x to the 5th to the 3rd times, I'm going to distribute that 2, that would be 2 squared times x to the 7th squared. Okay, go back up, clean it up, 3 cubed, 3 times 3 times 3, that would be 27 times x power raised to a power, we multiply our exponents, times 2 squared, that's 4, and here's a power raised to a power, that's going to be x to the 14th. Okay, I've got two numbers here, 27 times 4, we can do that. 27 times 4 would be what? 108, is that right? Okay, and then I've got an x to the 15th times an x to the 14th. They have the same base, so when they have the same base, the base stays the same, and I add exponents. I'm going to say my final answer is 108x to the 29th. Okay, that's how the rules that we have for exponents when it comes to various terms that involve multiplication. Okay, go ahead and work on that worksheet.